Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In this video, we're going to address something very important that comes as a follow-up, especially after being shown the fourth and the fifth assumptions in the previous videos that we needed for them to proceed with the statistical properties of the OLS. In this video, we're going to talk about the zero mean error in terms of conditional and unconditional mean. Which one do we use? What is the difference between the two, and which is the one that's more important? And why is there so much confusion in general with the students whenever we talk about the condition of the zero mean error? First of all, there is a very big difference between the two. So not just in terms of mathematics and the way that we write it, because obviously the unconditional mean, we write it simply as the expectation of the error term being equal to zero, while the conditional one is the expectation of the error term conditional on the x being zero. So clearly, mathematically, there is a difference. But there is a difference also conceptually with those. And in order to understand which of them is more important and why the confusion, we have to also understand, like, intuitively, that they are showing you different things, in fact. The whole first difference, and the most important one that comes from the intuition, is that while you can have the expectation of the error term equal to zero, that does not mean or doesn't automatically follow that the conditional expectation will actually be also zero. However, the opposite does get implied, which means that the unconditional expectation is a weaker assumption. Which means that when we go into checking our statistical properties, it means that this assumption alone will not be enough for the unbiasedness assumption. Take an example. Again, people with higher education have systematically lower error term. But overall, the average of the errors across the sample will still be zero. So in this case, the OLS will be biased. So let's look, now that we have shown intuitively the difference, and at the same time, the most important fact that makes the conditional mean expectation the stronger assumption and the one that is the more important, let's look into where does this all confusion come from. So in most of the econometrics books, you are going to see the expectation of the error term being equal to zero. And books that mention these, it's mostly in terms of the classical presentation of the linear model. So more in terms of the classical presentation. The Gujarati book uses this version, and actually it also lists it as the assumption 2. For the classical linear regression model. The Green book and other econometrics books sometimes uses this version, especially when describing the CLRM in matrix form. So in a sense, this is the old school way of introducing the model. But as we said, this version is too weak to give us unbiasedness. That's why the modern econometrics instead uses the conditional mean as the assumption. And you will see this, for instance, in the Wooldridge book. You will see it in the Angrist and Pischke book. The Green Book as well uses sometimes this variation, especially when referring to the Gauss-Markov assumptions. But overall, these are the two most important books that use this notation, and they refer as to one of the assumptions, the conditional zero mean rather than the unconditional zero mean. Now, let me show you very quickly also, why is it automatically implied by the conditional assumption, the unconditional one? So it is a fact that the expectation of the error term is actually equal to the expectation of the conditional expectation. So we're using the law of iterated expectations in here. So that means that if the expectation of the error term conditional on the x is 0, automatically the whole thing will also be 0. Okay? And again, this is why the Wooldridge or the Angrist and Pischke books don't even bother listing this error term unconditional mean equal to 0 as an assumption, but they just assume it as being built in. So overall, when you see the unconditional mean 0 in some books and conditional mean 0 in others, now you know the reason why. The unconditional version is a very classical assumption. The conditional version is the modern one, and it's also the one that it's very key to the unbiasedness and consistency and the statistical properties that we're going to talk in our future videos. So keep that in mind whenever you look at your lecture slides and whenever you have doubts on like, wait a second, but I have seen this other condition before. Okay. Hope this was helpful to clear out some of your doubts, and I'll see you in the next video.